Hi, in this video, we are going to discuss about integrators and differentiator. So, what is an integrator? An integrator is a circuit that performs mathematical integration of the input signal, and a differentiator is a circuit that performs the mathematical differentiation of the input signal. So if you consider the output of an integrator, then output of the integrator is proportional to the area of the input waveform over a period of time. And for a differentiator, the output is proportional to the rate of change of input signal. So here you have the output is proportional to rate of change of input signal, rate of change of input signal, and whereas for an integrator, the output is proportional to area of the input waveform over a period time, area of the input over a period of time, a period of time. Okay, now let us consider the circuit diagram for an integrator and for a differentiator. Now, first of all, let us draw the integrator. For the integrator, first you have to ground the non-inverting terminal, and the inverting terminal you have an input resistance, you have a resistance R1. Now generally we have a feedback resistance here. Now instead of the feedback resistance, we will connect a capacitor here. So you have a capacitor C1 here, and this forms our integrator circuit. Now in order to construct a differentiator circuit, again I am connecting ground to the non-inverting terminal. Now I have first of all I will draw a structure like this. Now what I will do is I will change the position of R1 and C1. So instead of R1, I will connect the capacitor here. So here I have the capacitor C1 and the resistance will be here. Resistance R1 is here, and this forms the circuit of a differentiator. So what I did is I changed the position of the capacitor C1 and R1 in the integrator. And the first circuit will work as an integrator, and the second will work as a differentiator. And if you give a ramp voltage, if you give a triangular input here, let's change the color. So I am giving an input like this. This is a triangular wave. Now if you differentiate, so the output waveform will be a differentiation of this input waveform. And you apply the input waveform and differentiate the rate of change of the input signal ആയിരിക്കും നമ്മുടെ ഔട്ട്പുട്ടിൽ കിട്ടുക. Now if you consider the ramp voltage, first നമുക്കുള്ളത് ഇങ്ങനെ ഒരു വോൾട്ടേജ് ആണ്, അല്ലെങ്കിൽ ഒരു ഫസ്റ്റ് if you consider this triangular waveform, ഫസ്റ്റ് നിങ്ങൾക്കുള്ള പൾസ് ഈ ഷേപ്പിലാണുള്ളത്. Now ഈ ഷേപ്പിന് ഒരു കറസ്പോണ്ടിങ് സ്ലോപ്പ് ഉണ്ടാവും. It will have some positive slope. Then you have a shape like this, അതായത് ഈ പാർട്ടിൽ. So correspondingly you will have another slope value, negative value ആയിരിക്കും സ്ലോപ്പിന്. Now you have another positive slope. Okay, then you will have some another negative slope. Okay, so if you connect this circuit, you will get a square wave in the output. So if you give the input as a triangular wave, for the differentiator, the output will be a square wave. Okay, now suppose you give a square wave here for the integrator, then what will be your output? So your output, if I give a input like this, ഞാനിവിടെ ഇൻപുട്ട് ഇങ്ങനെ കൊടുത്താൽ ഔട്ട്പുട്ട് എനിക്ക് ഇങ്ങനെയാണ് വന്നത്. സോ ഇവിടെ എനിക്ക് ഫസ്റ്റ് ഒരു പോസിറ്റീവ് സ്ലോപ്പ് ആണുള്ളത്. അപ്പം എനിക്കൊരു പോസിറ്റീവ് ഇവിടെ ഒരു അപ്പർ വന്നു, ദെൻ താഴേക്ക് പോയി, ദെൻ അഗെയിൻ മുകളിൽ താഴെ വന്നു. ഇവിടെ നിങ്ങൾ സർക്യൂട്ട് നോക്കിയാൽ ഇവിടെ ആദ്യം തന്നെ എനിക്ക് ഡൗൺ താഴെയാണുള്ളത്, ദെൻ ആണ് പോസിറ്റീവ് സ്ലോപ്പ് വന്നത്, ദെൻ നെഗറ്റീവ് താഴേക്ക് പോയി, ലോ വാല്യൂ ഹൈ വാല്യൂ, അങ്ങനെയാണ് നമ്മുടെ ഉള്ളത്. ഇവിടെ ലോ വാല്യൂ ഹൈ വാല്യൂ അങ്ങനെയാണ് ഇൻ്റഗ്രേറ്ററിൽ കൊടുത്ത ഇൻപുട്ടിലുള്ളത്. അപ്പോൾ നമ്മളുടെ ഔട്ട്പുട്ട് ഇവിടെ വരുമ്പോൾ നേരത്തെ ഉള്ളതിൻ്റെ ഓപ്പോസിറ്റ് ആയിരിക്കും, അതായത് നേരെ തിരിച്ചായിരിക്കും ഉണ്ടാവുക. ആദ്യം നമുക്ക് നെഗറ്റീവ് സ്ലോപ്പ് ഉണ്ടാവും, ദെൻ പോസിറ്റീവ് സ്ലോപ്പ്, then നെഗറ്റീവ് സ്ലോപ്പ്, പോസിറ്റീവ് സ്ലോപ്പ്. Okay, so if you give a square wave to the input of an integrator, you will get a triangular wave. And for differentiator, if you give a triangular wave as the input, the output will be a square wave. Now let us see the circuit once again. The two circuits are nearly identical. The first one is an OPAMP integrator. The second one is an OPAMP differentiator. And the only difference between these two are the placement of the resistance and capacitance. Here you have R1 and C1 like this, and here we interchange the position of R1 and C1. As we discussed, an integrator is a circuit that performs the integration of the input waveform, and the circuit consists of an amplifier. You have an input resistance and a capacitance in the feedback network. And if I give an input signal here, Vi, then the output VO will be the integration of the input signal waveform. Now let us analyze this circuit. So what we know is we will have a virtual ground here, and also the input impedance of the op-amp is infinite. So the current I will be equal to this current I. The current I will be equal to IC. There will not be zero current to the input of the op-amp. So we can write down I is equal to IC. Now IC is the current through the capacitor. We know that V is equal to IR. So I is equal to V by R. So I will be equal to VI minus 0 by R. Equation അങ്ങനെ വന്നത്, what is I? I is equal to I എന്ന് പറഞ്ഞാൽ VI minus 0 potential, that is VA by R വരും. That is voltage across R by R ആണ് I. I is, so this is voltage across R by R. Now what is voltage across by R? Voltage across R will be equal to VI minus VA by R, and we know that VA is 0, so this will be VI by R. Okay, so that's about I. So now what about IC? IC is the current through capacitance. Now we know that the equation we have I is equal to, current I is equal to dq by dt, and the capacitance will follow the equation Q is equal to CV. So if I substitute this equation here, the capacitance C is defined by the equation C is equal to Q by V. From here I wrote this above equation. So if I substitute here, then current I will be equal to d derivative of CV by dt, and we know that capacitance is a constant, so this is C dV by dt. So that's about the current I. Now here the notation is IC. So IC will be equal to the current through the capacitance. IC will be equal to capacitance C into voltage across capacitance by dt. So IC will be equal to C dVC by dt, and we have I is equal to VI by R. So what we now is having is VI by R is equal to C into dVC by dt. VC. VC is the voltage across capacitance. VC is the voltage across the capacitor C. And what will be VC? So VC will be equal to the 0 volt minus this V0. So that will be equal to minus Vz. Okay, so if I substitute it here, Vc is equal to minus V0 here, then this equation will be equal to minus C into dV0 by dt. So our equation will become Vi by R is equal to minus C dv0 by dt. So I can rewrite the above this equation as dv0 is equal to minus 1 by rc vi into dt. So the output potential VO will be equal to minus 1 by rc into then integral of vi into dt. Since r and c are constant, I can take it outside the integral. So now output potential VO is equal to integral of the input potential, input volt. And also we have a scale factor 1 by RC here, and you have an inversion, that is minus sign. So the output is an integral of the input with an inversion and a scale multiplier 1 by RC. So this is the working of a integrator. The working of an OPAMP differentiator. The circuit consists of an operational amplifier, an input a capacitor in the input circuit, and you have a resistance in the feedback network. And if you consider the circuit with the integrator, the position of the capacitor and the resistance is interchanged. Okay, now we know that because of the virtual ground, the potential at this terminal A, at the point A, will be 0 volt. And also the op-amp has infinite input impedance. So I can write down IC is equal to IR. All the current that passes through this capacitor C will pass through the resistance R. Now what is IC and what is IR? We know that the current through a capacitor I is equal to C into dV by dt. This is we have already shown. So I can write down IC is equal to, that is this term, IC is equal to C into dVc by dt. Now what about IR? IR is equal to the potential at this terminal, that is 0 minus V0 by R. IR is the current through this resistance. IR is the current through this resistance, and current through this resistance will be voltage across this resistance by the value of this resistance, and voltage across this resistance will be the 0 volt minus V0 by, then for current I have to divide by R. Okay, so this will be equal to minus V0 by R. Okay, so we have IC is equal to IR. So dVc by dt is equal to minus V0 by R. Now what is Vc? Vc is the voltage across this capacitor Vc, and that Vc will be equal to voltage input Vi minus 0 voltage, or that is equal to Vi. So Vc is equal to Vi. So this equation can be written as C into dVi by dt is equal to minus V0 by R, or the output voltage V out is equal to minus RC dVi by dt. So the output voltage is equal to minus RC times the differential of the input voltage. So for a differentiator, the output is the differentiation of the input voltage with an inversion and a scale multiplier of RC.